Okay, so today we're going to be solving log equations. That means that it starts with the word log somewhere in the equation. So I'm going to go through the steps, and if I'm going too fast, then you can just pause the video. So first we're going to condense to one log if necessary. That's using either the product rule or the quotient rule that we had from a few days ago. All right, then you're going to convert to exponent form on both sides. So you're going to choose the base by looking at whatever the log's base is. You're going to solve like normal. Now on these problems, you might have solutions that don't actually work in the original problem, so those are called extraneous solutions. And so therefore you need to check for extraneous solutions. Okay, so we're going to do problem number 1. We're going to look at what is the log's base. All right, actually, step number 1, there's only one word that says log, so we don't have to do step 1 for that one. Step 2, we need to look at the log's base. So notice that the log's base is 3. And so I'm going to be raising these to this power. So I'm going to do 3 to this power. So 3 to the log base 3 of x plus 1. And since I did that on the left side, I have to do the same thing on the right side, so 3 squared. Okay, so all I did was these become my exponents and my bases are 3. And I didn't just randomly pick the number 3, I picked it because that log has a base of 3. All right, so now if you remember your rule from a few days ago, if you have 3 with log base 3, these cancel each other out. So all that's left is x plus 1 equals 3 squared. And then now we can just solve. You guys know how to solve. So it's x plus 1 equals 9. And then I can subtract 1 and I get x equals 8. So there's my answer. What I mean by check for extraneous solutions is just double check. If I put 8 back in here, 8 plus 1, that gives me 9. That's a positive number, and that's okay. So I have to have what's in the parentheses here. It has to be positive. It can't be 0 and it can't be negative. So this is good. All right, problem 2. First we're going to condense. All right, so that's step number 1. Notice that it's subtraction, so we're going to do our quotient rule. So we've got log base 4 of 100 over x plus 1. We're dividing 100 over x plus 1, and that equals 1. All right, step 2, we're going to convert it to an exponent form. So my log's base is 4. That means I'm going to write 4 to the log base 4 of 100 over x plus 1 equals, and on this side I also need to do 4 to the first power. So these things became my exponents and my bases were 4. Okay, so now we're going to use our shortcut rule. If we have 4 with the log base 4 in our exponent, then those cancel, so I just have 100 over x plus 1. And then 4 to the first power is just 4. So now you can solve. If I want to get rid of the x plus 1 on both sides, I multiply by x plus 1. I get 100 equals 4 times the quantity x plus 1, which is 4x plus 4. And then I subtract 4 on both sides, so that's 96 equals 4x. And then in my final step, I'm going to divide by 4. Okay, so my final answer is x equals 24. Now I just need to go back and double check. This one, I don't need to substitute anything, but 24, if I were to put the 24 all the way back in here, 24 plus 1 is 25, which is positive, so that's okay. So that one works as well. All right, when you're ready, flip to the other side, then we're going to do 4 more problems. All right, so we're going to change these into exponential form. Look at my log's base, that's 5, so I know 5 to the log base 5 of x to the 4th, and I have 5 to the 8th. All right, so you should remember that the 5 and the log base 5 cancel, so all that's left is x to the 4th equals, now for this one, 5 to the 8th is going to be a big number, so that gives me 390,625. All right, so now to solve this, I'm going to take the 4th root of each side. That can undo that, so I'm going to do the 4th root of 390,625, and that gives me x equals 25. Actually, it gives me x equals plus or minus 25. So just like when you take the square root of both sides, you say plus or minus, you should have plus or minus here. Okay. All right, number 4, we have to condense first. So this tells me I'm going to do my product rule because it's addition. So I'm going to do log base 12 of x squared plus x. So that comes from doing x times x plus 1. X squared plus x. And that equals 1. All right, so now I need to look at what's my log base. That's 12. I'm going to do 12 to the log base 12 of x squared plus x equals 12 to the first. So you're making sure you do the same thing on both sides, 12 to these powers. All right, so my 12 and log base 12 cancel. I have x squared plus x equals 12 to the first is 12. So now, because I have a quadratic, I have to move everything to one side so it's equal to 0. So I get x squared plus x minus 12. This means I can solve using the quadratic formula, so I'm just going to run my a-quad program on my calculator. And I've got a is 1, b is 1, and c is negative 12. So my answers are positive 3 and negative 4. All right, so we're going to go back and check. Let's double check. If I were to put these numbers inside here, 3 is positive. That's fine. 3 plus 1, that's 4. That's positive. But negative 4, if I put that in here, that's negative. Even if I put it in here, negative 4 plus 1 is negative 3. That's negative. So this is considered an extraneous solution. So that actually does not work. Only positive 3 is our answer. Okay, 2 more problems. We're going to condense first. So we're going to bring this 2 up to the top. We've got log of x squared minus log of 4. Then we're going to condense using our quotient rule. So we've got log of x squared divided by 4 equals 0. Now what's my base in this problem? It's a 10. Remember, if you don't see a base, it's implied that that's a base 10. So now I want to do 10 to the log base 10 of x squared over 4 equals 10 to the 0. Okay, so remember, 10 and log base 10 cancel. So you're left with x squared over 4, and 10 to the 0 is 1. Anything to the 0 power is 1. So now you have to solve. Multiply by 4. X squared equals 4. Take the square root of both sides. X equals positive 2 or negative 2. But now we should just go back and check. If I were to put the number 2 into my original problem, 2 is okay, but negative 2 is not. So really, negative 2 is extraneous. So this solution doesn't work. This is the only solution. So it's not plus or minus 2. It's only positive 2. All right, last problem. We don't need to condense because these logs are on opposite sides of the equation. So what we can do is just go right to step 2, which was convert to exponential form. So you look at your bases. So we have 7 log base 7 of x plus 3 equals 7 of log base 7 of 4x minus 12. All right, so my 7 log base 7 should cancel. All I'm left with is x plus 3 equals 4x minus 12. Now you just have to solve. So I'm going to add 12 to both sides. X plus 15 equals 4x. Subtract x. 15 equals 3x, and divide by 3. So I get x equals 5. And then just double check. Is 5 plus 3 a positive number? That's 8. That's good. 4 times 5 is 20 minus 12, which is 8, so that's positive, so this is good.